Please.
Yay! Yay! Okay, so we can get on started. I'm the co-host. I am posting a welcome message and going out of the visible area, but I'll still be here reading the chat. I'll be back at the end to post a feedback form. Thank you for being here. Thank you.
And let me share my screen, go into presentation mode. And go back to the first slide.
Sure.
Okay, so here we are. Welcome, everybody. Oh, go ahead.
Oh, no, sorry. Hey, you go ahead.
Oh, did you want to read an intro or a bio or something, Ho-Chan?
Sure. Do you want me to read it or?
If you would like to, I don't want to screw up your flow.
Totally fine, but we're a little bit learning, late,
Then let's just go straight into it. Well, I'm Jerry Power. I'm CEO of i3 Systems, and what we're going to talk about today is a layered approach to network management. Let me get started by saying that in the world of IoT, which is how do you collect data from devices that are actually sensors reflecting the real world, how do you do that? And the normal operating mode is that you would sort of start with an application, or actually start with users, understand their requirements. From that, you pick an application, then you deploy IoT devices that support that application. And from then on forward, basically, once the data starts flowing and you've configured the systems, you use the application to manage those IoT devices. And I think that's sort of the standard accepted. If you look at the way most IoT applications have been deployed, that's sort of been the direction and how it's been done. But the result of this, when you sort of follow this paradigm, what you end up with is many data silos. And that is, data is sort of looked at as being a consumable of an application. It feeds the data to the application, and then basically you go, well, that's the end of the value of the data or the devices. It makes it very silos. It's very difficult in complex organizations to share data between departments. Complex organizations might be a city. So if you have different IoT applications deployed in a department within a city, it's really hard to share data between departments. And in the private world, you might have an ecosystem made up of a bunch of partners who have a legitimate need, or they want to share some data about how the partnership is working, about data rights to operationalizing the ecosystem, but it's sort of hard to share that data between partners. So effectively, this process that is sort of the accepted standard actually creates a lot of limitations that hamper the emergence of what I would think of as a more complete data-driven culture. And effectively, everybody here on the call, I mean, this is a data symposium. Everybody understands, and we want to move to being more data-driven in our decision-making process. But these silos inhibits its reuse. It actually takes a lot of people, if you do want to start sharing data between organizations. It requires lots of different coordination. Pulling in legal people, both departments, software people from both departments, the users. I mean, it really ends up in being quite complicated for how do you start sharing data across these silos. The other thing that happens is that to sort of manage these devices, some devices are managed with some set of tools out of one department. Another set of devices is managed completely differently out of another set of department. And if you want to sort of be able to manage your data cohesively, it means that you end up almost sitting in a swivel chair and swiveling between all these different applications, which are complicated applications, so they're difficult to learn. That leads to operational expense because of the people, and these complexities are so insurmountable that a lot of times people actually give up on trying to share data. And the result is that really limits strategic alternatives that might be otherwise would be open to the organization. So there's some real drawbacks to sort of going, if we continue to go down this legacy design road. So what we did is we started, as we were thinking about this, we started looking back at how the internet was how it evolved, where it started, and the process it went through. It did start early days of the internet. All the data, all the users went to one application, and the application sort of managed their access to the internet. If you think back about the days of AOL or CompuServe, there were these gateway applications that managed our experience on the internet. But over time, we started to realize that users were capable, given the right tools, users were capable of managing their own experience, and business sites could manage their own as well. So really, there didn't need to be these gatekeepers involved in the process. Trying to get there was done by basically taking a look at the internet and layering it out as a series of layers, where each layer, the one layer provides services to the layers above it, and on the other side, looking down, each layer uses the services provided by the layers before that. And by breaking it, only by breaking it into those segments were they able to get their arms around the individual problems being solved, addressed by each layer, and begin attacking and make progress instead of looking at the internet as a super big application where everything needed to be coordinated. We started thinking about that internet design philosophy, and we came to the conclusion that really there's different layers even in a data system. That there's the user interfaces that basically present the user data in a way that they can make use of it. They're the data architects, people who sort of work on collecting the data and feeding it into a common repository. And these two functions are really quite different from each other. So that leads to the question, all right, this is where we want to get to. How do we start getting there? And that was sort of the focus of the next slide. One of the first things we did is we started thinking about existing applications and tried to break them into functional modules. And we saw the UX, the GUI function, as being something very unique and specific. The people who work on this have to understand how people are going to use the data, how you want to present it to them so that they can actually do something intelligent with it. And that requires a certain kind of expertise. We also then broke the database layer out and thought about how do you store data, how do you make it so it's easy to retrieve, how do you figure out how much data you actually need to collect so that you're not collecting 3 or 4 different data items that are all very similar to each other, but instead really trying to be efficient about the way the data is collected, what's stored, and how it's made available to the users. The other thing we added, and then this is going to change a little bit in a few upcoming slides, but because the database has a schema in it, the IoT devices don't all report data the same way. So you need to have a way that sort of takes the raw data coming from the IoT devices and mapping it into that database structure. And for lack of a better description of it, we call that a schema interpreter. If I go down to the next layer, so what we did then is started saying, well, where should we move these? And right away, it became pretty clear that the UX and the GUI function really should be treated as a separate and independent layer from the actual engine that stores the data. So that was something that we thought was pretty important to do. When you did this, it became really clear that by breaking this down in layers, you could actually start implementing things like data brokers. So data brokers is basically, if you think of a data broker, it's an application, a function, maybe a microservice, that might be a better word for it, where you're reading data from a database, maybe one element maybe a bunch of different elements, but you read from the database, use the database in that read, and manipulate the data to create a new data item that hasn't been there before. You can then reinsert it back into the cloud environment. So you might take, whether it's over time, a series of readings that maybe come in every month, and maybe you do every minute. Maybe what you do is then you do an average to sort of say, all right, well, here's that average data for that every minute, and now you've compressed the data effectively from being 60 reports inside a minute to 1 report inside a minute. But you could do that in time. You could also look across different data items. For instance, the data broker might read data from sensors that are gone up and down in a block area and sort of compress it to sort of say, here's the value of that data on average in the block. So there are ways that becomes really easy to sort of take that data and then manipulate it and provide value-added services on top of it. So that was, I think, pretty interesting way to think about things. The other thing we did, we added into this the idea of a governance layer. And what we were thinking about there was in terms of privacy, security, and things like that. How do you start managing them, but not adding that complexity into the database, but sort of managing it below the database, so that you're limiting the data that goes into the database based on policy. So if you want to exclude certain data items from the database, by doing that below the database, I think you have a cleaner vision as to what's being stored and what's not being stored. So when you report to people, here are our privacy rules, and we store this data, we don't store this data, you now have a clear line of demarcation between the database and the governance layer for where that's actually implemented. So we thought that was a good thing to be done as well. I know there's a lot of work being done in standards, trying to standardize database schemas. Probably more people working on that than I even know about. But what we also tried to think about was that the data infrastructure is not going to be static. If you built the world's ideal data infrastructure today, I'm sure 2 years from now, there would be new things that were happening that would sort of invalidate that perfectness of that infrastructure. So you sort of have to think about an infrastructure as something that evolves over time. When standards start appearing for IoT devices, certainly we accept that there are some IoT devices that are going to be made super smart and they're going to totally conform to the standards. That will happen. In that case, you don't really even need a schema interpreter. You just feed the data from the device into the database. And I said that based on standards, but maybe even the device includes tools that lets you sort of reformat and change the data differently as it flows out of the device. There will be cases, however, where some devices are not that smart, so you may still need a schema interpreter. You could sort of move that over time out of the database environment. You could move that into the governance function or even into an independent front-end processor that sits below the data governance function. But ultimately what you're doing is you're sort of stepwise moving the schema interpreter further and further towards the edge until ultimately it's in the IoT device. And given enough time, I think ultimately we will be in that kind of a position where lots of IoT devices give you the choice of what standard interface upstream you want to present the data in. It'll be a while from where we're at today, but you've got to start thinking that there's going to be stepwise iterations as we move toward that point in time. I put some quotes up here to talk sort of about some of the things that we think shape our thinking in this space. Certainly, this is a quote from Mark Twain. He was not a software or data guru, but He was an incredibly practical person, and he made the observation that by breaking big tasks down into functions, it's much easier to start making progress. And we totally adhere to that. We believe that that's the way you have to start think about problem solving. The other thing, and this is from Simon Sinek, where the question is don't wait for perfection to start. And once you take Mark Twain's and Simon's comments together, what that says is that you have to think that once you break your task down into manageable tasks, then what you have to do is sort of build the system so that each of the manageable tasks can evolve at different rates. So that if one team's working on the GUI, they may evolve their system over time at one rate. Maybe the people working on the database evolve at a different rate. And you need to be able to support that asynchronous nature of these development tasks. So that becomes something important as well. And then the last thing is from Godfrey is more about data. I know everybody here is a data advocate. They believe in data, so that's sort of preaching to the choir in a lot of sense. But what we want to do is sort of, as we're thinking about data, we don't think about data as sort of starting with a data set, doing analytics, and then generating results. We're trying to think of that next way forward where IoT devices are generating the data, the analytics gets run, and then from the actionable outcomes, it's actually directly driving changes in the physical world, which is a lot of the same principles. We've just extended that thought process to the next logical level. This is the picture that we think about, and we think about data ecosystems as being something that constantly evolve over time. And you could sort of pick anywhere on this wheel and sort of start. And for this kind of time, you could sort of say the IoT devices generate the data. It goes through a cleansing process. It's stored. The data is enriched. We talked a little bit about that already. You analyze the data, present it to users. From that, it drives actions, which actually might drive commands back out to the actuators in the network. And then that again changes the data. So what you have is sort of, instead of thinking about data as a fixed point in time that you're working on to get answers out of it, it becomes sort of this evolving system that's constantly sort of self-improving itself. And that's really where we're trying to get to. Some of the things that we think are important, we've tried to build into the i3 system. i3, we released our, just a bit of a commercial plug here. We released our software last month, so it's relatively new on the market, but some of the features we thought that were important and are included in release 1 is being able to log the data as it flows, activations and deactivations of data streams, being able to take data streams and feed multiple applications, make it easy for applications to find data that is of interest, manage the permissioning process where applications who are interested in data actually apply to get access, but the data producers approve or disapprove the process. That's an important thing to think about. Supporting dynamic access to data streams, so not ad hoc, but just sort of really thinking through how do you do this for a short period of time and be able to release it instead of having to always set up long-term permanent data flows. We built into the system also the ability to support different data protocols and then administrative support between the teams so that not everything goes to a common point of failure, like if all the approvals go to one person or to one team. Backlogs build, and that delays how quickly you can pass data between organizations. So it's pretty interesting. Let me pause for a sip of water here. This is an illustration of a project we're working on with the City of LA. City of LA has video cameras on their sanitation trucks. Sanitation trucks drive over all the city streets on a scheduled basis relatively regularly. Right now, the video cameras on the sanitation trucks are being used to support the sanitation department, basically collecting data about driver safety, collecting data about their ability to pick up refuse on the side of the road. Like if cars are blocking it, they can sort of make a record of here's why we couldn't get your garbage. So they're doing lots of things with video in support of the sanitation department. But the city understands that the video coming out of those cameras has value to other departments in the city that are, and those value chains are not being tapped. For instance, one of the things you can do, these cameras that are on the trucks, as they drive over the streets, they can, every week they drive over it, they can make a recording about a pothole, a crack in the road. And then by looking at the data over time, all right, here it is over 4 weeks. Let's look at it, maybe 8 weeks. It's getting bigger at this rate. This means we'll need to go out and fix that specific pothole sometime in the next 6 months because that's when it goes critical. Now, right now, the city does this. It waits for people to sort of go out with their cell phones, take pictures of potholes, and report the pothole back to the city. But if you sort of move and start doing this dynamically based on the video cameras on the truck, the city is now becomes much more proactive about street repairs because they basically cut out that need for somebody to go out and report the data. The other thing that's interesting about it is that if the city is able to forecast, here are the potholes getting bigger, and they know where all of them are and when each of them goes critical, instead of sort of dispatching a crew to fix a pothole that needs repair, they go back to the depot, reload with the supplies, and go fix another one maybe on the other side of town. What they can do is actually schedule the trucks to go out with enough things, supplies in it, maybe cover 6-10 potholes in one area that where maybe one of them is critical, but the other ones are going to turn critical in the next 2 months. So let's get these fixed while we're out there. So that actually helps a lot with operational efficiency because the trucks make fewer rolls, and they're much more efficient when they're out in the street. And that's just an example of how data from a garbage truck can actually improve road conditions. But there's other things that can be done. The same video on the garbage truck can be used to identify graffiti that needs to be cleaned off walls. It can be used to identify objects that are at the side of the road that are not supposed to be there. Maybe somebody has to go out and do a special cleanup. Or if vegetation, somebody hasn't been taking care of the vegetation around their property, maybe you need to send out an inspector to sort of check it out and see what has to be done. But there's just a lot of things that video coming off of the truck can be used for if we can harness the data and use it as a common asset that's not locked into the Department of Sanitation, but analyzed differently and used to drive action through the rest of the city. So this is sort of the long-term vision of kind of how we see things. We think there are a bunch of cloud applications that do sit out there, and I probably should draw this into the slide. There's a database function. There's an i3 processor function that manages the data governance. In this slide, I've shown the front end, the edge processors that might be there as well, and then driving the devices directly. So you see a very layered approach to how we think about data as an infrastructure. So sort of to conclude, kind of wrap things up a little bit, what it is we do think that the existing deployed data systems are often designed to lead to enforce and reinforce silo processes that tends to insularize data systems. That there are significant gains that if we move away from sort of the way we design these legacy systems and think about them as layers where each layer builds on each other, it makes the data much more open, accessible, and ways to sort of build value as the data flows through the infrastructure. And that's a better path forward. The other thing that we point out that we think is that ultimately what we're talking about here is something that has to happen. As data complexity increases, just like the internet, they had to move away from AOL into sort of today's layered structure of the internet. that had to happen before the internet could be the ubiquitous tool it is now. So we think it's there. It is coming in our future. And i3 is certainly working to accelerate progress in that direction, because we think this opens up a whole new area for how we use data and what we do with it. And with that, I'll pause. And let's look at any questions that we might have. I think I have till 2 o'clock? Is that how long we have? Ho Chan? All right, so let's look at the first question. Oh,
I think you good until 2:05.
2:05? Okay, so we got another 15 minutes. And so let's talk through it. So somebody saying, glad to meet me. That's good. Exceptional conference, great speakers. There's just a comment there. I don't see any specific questions listed in the chat box. So while we wait, if you do have questions, by all means, feel free to type them into the chat box. The best way to reach out to me, I know in the session agenda, it gives my LinkedIn address. That might be the best way, the easiest way, because you can just click on the LinkedIn and then send me a message. So that's pretty cool. So if we don't have any questions while we're here, I'll just talk a little bit and I'll tell maybe more stories. So one of the things the example I gave was about sanitation.
Hi, there are 2 questions in the Q&A. I was trying not to horn in, but if you hit the Q&A tab, you can see them, or I can read them to you. I'm sorry, I didn't mean to.
I was watching the chat. Sorry.
Yeah. No, there's 2 different ways to chat, and one is called Q&A. Can you see the tab? It's the rightmost one, or here.
So the first question is an interesting question. Is this new data management approach leaning toward the public arena and sector? And I don't know. I'm going to say it's leaning towards it, at least initially. When we think about data, instead of thinking about data as something that was designed for a silo, we think about data as being designed to support a community. Community might mean different departments within a city, because most cities are organized as federated IT environment, where different departments have their own embedded IT specialist with a centralized staff that sort of does common functions. So how do you get these federated environments to share data, since it's still within the city, but typically siloed so that it can't be shared outside of those? When I talk about building communities of people who are interested in being able to share and use each other's data, that resonates immediately in government entities. Governments sort of were designed, developed, they grew up understanding that by working together as a community, we can do things that we couldn't do as individuals, whether that's as a community, we can build roads. Certainly not everybody wants to build a road in front of their house. So there are things in the data world that have analogs into the physical infrastructure world. And I think city people just immediately sort of grasp that, because that's sort of how they're brought up. In the private world, there are those communities as well, but they're not as strong as they are in the government space. I expect they will get stronger over time. Private industry sort of started thinking about business as sort of vertically integrated businesses, and the way to sort of do things was to manage the chain up and down, so you had complete control over what your organization did and what they had available, the resources available to them. I think as we continue to evolve, we see that vertical integration is, I don't even want to say being chipped away at, but pretty much completely undermined by the tools that the internet has provided, in that it's much more easy to set up federated groups of users to sort of work together to a common cause. even though those users may be independent companies. A good example that comes to mind, I think about the automotive industry. A lot of what the big automakers do, a lot of what they do is they subcontract out parts, services to a bunch of small companies, maybe they're still large companies, but relative to the auto companies, they're pretty small. And it's the federated group of people that work together on one car, and there could be a different group of people that work together, suppliers that work together on a different car. So I think you see that vertical integration rapidly disappearing. Certainly the research done in business schools shows that when you have ecosystems or partnerships, success is highly correlated with the ability of the groups to be able to share data between each other. I think that's a pretty proven fact. The issue, if you're a member of the ecosystem, is how do I share the data that I want to share with the people, with these specific people, knowing that 6 months from now, I could also be working on a different project, maybe even within the same ecosystem, but have a different set of partners. So I want to be able to turn on or turn off data flows between these members of the partnership. And I think there's also that need that will arise in the public sector, but it's not like inherently a part of their DNA that you see in government. How do you build ways to compensate for inaccurate data delivered by IoT? Or does one have to accept that some of it will be built into? So I think it's a good question. But I think the way that we think about it, it's not so much compensating for inaccurate data as much as how do you identify which is the most accurate, the best data. If you can sort of make that visible, it will encourage people, instead of giving inaccurate data, it will encourage them so that they want to give more accurate data. And that's kind of should be the goal, is sort of drive it from a positive standpoint rather than a negative. There's a couple ways to doing this, things that have to be done. One of them is you have to make data quality a visible part of the equation. So that if an IoT person, device or a set of devices is generating good data, and then it's acknowledged to be good data, you sort of want to be able to flag that data as being, this is really the best data. And I think you have to do that on the data side. I also think you have to sort of think about it on the application side, not just on the data, but who are trustworthy data processors, the more versus less trustworthy. In some ways, I think about that side of the coin being related to maybe how Uber, if you're aware of Uber, they basically let the drivers rate the passengers and they let the passengers rate the drivers. And hopefully that drives everybody to better behaviors on both sides. So I think that's a part of the issue. The second thing that has to be added to it is you have to have, and I think you called it compensate inaccuracies. I said we take more of a positive approach, where what we think about is being able to reward higher quality data at a different rate than the lower quality data. So you sort of want to use these two things together to sort of move the data world to a place where this is much more of an equitable and open process when you're transferring data between people.
When I saw that question, I thought of the person who ties their Fitbit to the dog or puts it on the ceiling fan. But I guess if you build in all the layers and you get enough data, that kind of thing that happens at the granular level really isn't gonna damage,
And there's two part of it, and a lot of people talk about, well, you do incentives for better data. But when you do think about incentives applied to better data, that's going to encourage people to sort of try and create more data and make it look like it's better data. So that's why you need sort of the rating mechanism on the other side. I do watch, and I pay a lot of attention to like what's going on social media and what is fake news and what is real news. Certainly that's a very topical thing to be talking about. And while everybody sort of agrees that you want to have good data on social networks, what you want to do also is think about that situation, but then apply that to the data environment. I mean, what is fake data? What is not fake data? That's not a question that any of the politicians have been asking themselves yet, but that's certainly a question that you could sort of easily forecast that will be a topic of conversation going forward in the future. So, yeah, it's a super interesting place. One of the things when I was at USC, we spent time researching what makes technology projects succeed or fail. And usually in talking to lots of CIOs and technology people, it's usually not the technology that's the problem. I mean, assuming you have enough budget and enough time, I mean, technology can do just about anything you ask it to. The real question as to what makes projects succeed or fail come down to these kind of human questions about inaccurate data. How do you stop people or encourage people not to give inaccurate data? And these are real people problems that you've got to think about when you deploy any new technology. So one of the questions here was, is this a government issue or not? I'll go back to that question just as a different example. One of the projects we're working on is with the Hollywood Business Improvement District and Smart City Labs. And what they're trying to do is move technology in that area to be more supportive of business needs. This is not a government function. The Business Improvement District is a private nonprofit entity that sort of serves the members in that community, but they sort of serve and do things that the city doesn't provide. If you think about Hollywood, as you walk up and down the street, it's a bunch of small, and I'll say mom and pop stores, although they are owned by other companies and some of them aren't totally small, but it's not a huge, incredibly large company. It's a bunch of small vendors, and they're hoping people walking down the street come in their store, maybe buy a coffee, maybe they buy some souvenirs. They each have technology that they've deployed. As you're walking down the street, if you look up in the eaves over the umbrellas, over the umbrellas that hang out over the street, you can see video cameras. They all have alarm systems. For those that are interacting with customers, have retail point of sale terminals. So there's a lot of technology that goes to support those kind of stores. But what the Business Improvement District understands is that if we took the data that comes from each of these individual stores, so we got 2 minutes, and pull it together, we could derive insights about what's going on in the neighborhood that would be beneficial to the store owners. For instance, over the course of the day, the composition of the people walking on the streets change. You could pick that up, not by looking at an individual store, but by looking at neighborhoods. You could sort of sense that, send messages out to the store owners, and they might change their advertising strategy, with dynamic in-window electronic displays. Maybe they have special coupons, sort of at the table that pull up when you have your electronic menu there. But you can do a lot of things as a community of merchants that you couldn't do, that a city couldn't do, and that certainly the individual stores couldn't do by themselves unless they sort of pull together and think of themselves as a data-centric community. With that, I see we have a minute, maybe less. So again, if you're interested in continuing any of the dialogue, by all means, feel free to reach out to me through my LinkedIn profile. It's Jerry Power.
Thank you, Mr. Power, for your great presentation.
Thank you. Please, attendees, take the time to fill in the feedback form so we can continue to make this a really great conference. And thank you, everybody. Thank you, Jerry. Thank you, Ho-Chan. I'll see you at the party later.
Sounds good.
Yeah,
thank you.
Definitely. Thank you so much. Have a wonderful day. Thanks for your help.
Thank you, too.